Stop multiplying your angles by 2.28 and then dividing by it again. Some time ago, a massive effort was expended to convince the programming world to replace approximations of pi with approximations of tau. The idea, according to numerous blog posts and YouTube videos, was that common formulas become simpler when you use a constant describing an entire circle instead of half a circle. Generally, the author agrees. While it is a minor point, it is worth making. Most code does get slightly better if you replace pi with tau. However, in all the fanfare, a far more impactful opportunity was overlooked. Instead of replacing pi with tau, most of the time pi can be removed entirely from your codebase. This is the core argument that usually gets lost in the noise. First, consider the common case for pi and tau in code, converting things to and from radians for calls to trigonometric functions. If you have ever used these constants, the vast majority of what you wrote probably did something like adding a center coordinate, multiplying by a value h, and then multiplying by tau to call the sine function. The author did not make up this example. They randomly opened the source code for the Godot engine on GitHub and searched for tau. The piece of code above, and dozens of similar uses, is what comes up. There is nothing special here about Godot. If you opened any random game engine codebase, you could do the exact same search and see the exact same kind of usage. Notice what is going on here. The programmer has a value h which is already periodic on the range 0 to 1, but they multiply by tau because they need to call Sine. This may seem very sensible if that is as far as you look, but what about the implementation of Sine? There are many implementations of Sine, but no matter which one you look at. Near the entry point of the function, you will see something like a constant definition for 4 divided by pi. The implementation multiplies the input by this constant. So the calling code is doing this. Multiply by 2 times pi, but the library code immediately divides by pi. You are multiplying by 2 and then dividing by 1. It is a double conversion that serves no purpose. The solution is to use turns. A turn is simply one full rotation. If you use turns, your periodic value is already in the correct unit for a lookup table or a simplified sine implementation. You do not need to multiply by tau to convert to radians, and the sine function does not need to divide by pi to convert back. The code becomes simpler, faster, and more precise. The author argues that this is a far more impactful change than the pi versus tau debate because it removes the constant entirely rather than just swapping one irrational number for another. This is a pretty common technique in digital signal processing when using fixed point even today. One commenter noted that fixed point is sadly underutilized and unknown for so many people in the profession. Another pointed out that you can encode units in the smallest precision, so you just have integers with no floats and no float accumulating errors. A 25/6-degree circle is really useful for games. You can do trig with a lookup table with adequate accuracy and not excessive storage, at least for 16-bit systems. And later. This suggests it is one of those things that has been forgotten by modern developers. While discussing performance, one commenter shared an interesting anecdote about sorting a list of points by their distance from another point. They realized they could eliminate all of the square root calls by just sorting by distance squared. Another commenter added nuance, noting that modern CPUs come with a dedicated instruction for square root, but squaring is still a lot faster to compare distances. Some argued that those instructions are still slow as hell. The consensus is that avoiding unnecessary math operations is always a win for performance. When it comes to square roots, one commenter suggested to just drop the magic number, Xerox 5 F3759DF in your code instead. They noted that it is not necessarily because it is faster, but because it is funnier. This refers to the famous fast inverse square root algorithm from Quake III. Arena, it is a great example of how low. Level optimization can be both practical and entertaining. The humor in the comments reflects the community's appreciation for these clever tricks. The takeaway is to look at your code. If you are multiplying an angle by tau and then calling a sine function, ask yourself if you can just use turns. It simplifies the code, reduces the chance of error, and might even speed up your hot path. The author's article provides a clear argument for why this shift in perspective matters. It is not just about constants. It is about the units we choose to represent our data. Choosing the right unit can eliminate unnecessary work. Thanks for watching. If you found this breakdown useful, hit like and subscribe for more deep dives into open source and dev tools. Check the description for the full article link. See you in the next one.